Number system, natural numbers, counting numbers 1, 2, 3, 4, 5 are called natural numbers, whole numbers, all counting numbers together with 0 from the whole numbers, then integers. All natural numbers 0 and negative of counting numbers together form integers. Positive integers is a set of all positive integers, then negative integers is a set of all negative integers, then real numbers. All numbers that can be represented on the number line are called real numbers. Every real number can be approximately replaced with a terminating decimal. Then modulus of a real number. Modulus of a real number is defined as like this. Here a minus a if a greater than equal to 0, minus a if a less than 0. Prime numbers, a number greater than 1 is called a prime number. If it has exactly two factors, namely 1 and the number itself, then prime numbers, a number greater than 1 is called a prime number if it has exactly two factors, namely 1 and the number itself. Then prime numbers up to 100 given, then divisibility by 2 or 5. A number divisible by 2 or 5 if the last digit is divisible by 2 or 5. Example given. Then divisibility by 3. All such numbers, the sum of whose digits are divisible by 3 are divisible by 3. Then divisibility by 4. If the last two digits are divisible by 4. Then divisibility by 6. A number is divisible if 6 by 6 if it is simultaneously divisible by 2 and 3. So divisibility by 8. A number is divisible by 8 if the last 3 digits of the number are divisible by 8. The number formed by last 3 digits, namely, is divisible by 8. Then divisibility by 11. A number is divisible by 11 if the difference of the sum of the digits in the odd places and the sum of the digits in the even place is 0 and is divisible by 11. Divisible by 12. All numbers divisible by 3 and 4 are divisible by 12. If n consecutive whole numbers a plus 1, a plus n minus 1 and only 1 is divisible by n. A sum of 5 consecutive whole numbers will always be divisible by 5. A square of an odd number when divided by 8 will always leave a remainder of 1. The product of any r consecutive integers numbers is divisible by r factorial. If m and n are two integers, then m plus n in factorial is divisible by m factorial into m factorial and factorial. Difference between any number and the number obtained by writing the digits in reverse order is divisible by 9. Then any number written in the form of 10 raised to n minus 1 is divisible by 3 and 9. A raised to n by a plus 1 leaves a remainder of dash a if n is odd and n is even. Rule of finding out HCF and LCM of fractions. HCF of two or more fractions is given by HCF of numerator, LCM of denominator. LCM of two or more fractions is given by LCM of numerator, HCF of denominator. Then rule of HCF, if the HCF of x and y is g, then HCF of x plus y is also g, x minus y is also g, x plus y, x minus y is also g. Calculation of units digit when a number is raised to a power. Find out last digit of the number and power of the number. Write power of the number in 4n, 4n plus 1, 4n plus 2, 4n plus 3 form. Then check the table and you will get unit digit in given expression. Find the unit digit of 52 raised to 97 into 43 raised to 72. So 97 is equal to 4 into 21 plus 1. So 4n plus 1. Last digit of 53, 2. So 4 to 2n plus 1 will 4n plus 1 will have unit digit 2. 72 is equal to 4 into 18, 4n. Last digit of 43 is equal to 3. So for 3, 4n plus 0 will have unit digit 1. Product will have unit digit 2 into 1 is equal to 2.